Have you ever looked at a photograph from long ago? A picture of the world in its infancy? Imagine we had such a photograph of our entire universe, taken just moments after its birth. A snapshot of creation itself. We do. And on that first, faint picture in the ancient light, scientists found something that shouldn't be there. A vast, deep, and impossibly cold bruise. Tonight we journey to this cosmic anomaly, known as the cold spot. We will explore the veil of this great mystery and ask a question that whispers at the edge of science. Did our universe once touch another? To begin our journey, we must travel back in time, back almost 14 billion years, to the dawn of everything. In the moments after the Big Bang, the universe was a hot, dense sea of light and energy. As it expanded and cooled, this light began to travel freely through space. Today, that ancient light is still here. It fills every corner of the cosmos. It is called the cosmic microwave background, or the CMB. It is the oldest light in existence, the faint, residual heat of creation. Scientists created a map of this light, a baby picture of our universe. They expected to see a nearly uniform temperature everywhere, with only the tiniest variations. And they did, except for one place. There, in the direction of the constellation Eridanus, was the anomaly, a patch of sky far colder than it had any right to be. This was not a small irregularity. The cold spot is enormous, stretching over 1.8 billion light years across. To put that in perspective, our own Milky Way galaxy is only 100,000 light years wide. You could fit thousands of our galaxies into this single, cold patch. It is a feature of such immense scale that it challenges our very understanding of the universe's structure. Imagine floating in a warm ocean and suddenly entering a current of inexplicably icy water that is wider than a continent. That is the feeling this discovery gave to astronomers. The temperature difference itself might sound small. The cold spot is only about 70 microkelvins colder than its surroundings, a tiny fraction of a degree. But in the precise world of cosmology, this is a colossal deviation. The standard model of cosmology, our best map of how the universe works, simply cannot account for a cold patch of this size and intensity. The odds of it forming by random chance are less than 2%. It is a statistical improbability, a detail in the grand portrait of the cosmos that seems to have been painted with the wrong color. So the search for an explanation began, leading scientists down two very different and equally fascinating paths. The first path leads us to a simple, if staggering, explanation. Perhaps there is just nothing there. Or, more accurately, far less than everywhere else. This idea is known as a supervoid. Imagine the universe as a grand cosmic web, with long filaments of galaxies and dark matter connecting dense clusters like cities on a map. Between these filaments are vast regions of relative emptiness, the cosmic voids. A supervoid is the largest of these, a colossal ocean of near nothingness. The theory suggests that the cold spot is not cold in itself, but is instead an optical illusion caused by a supervoid that lies between us and the ancient light of the CMB. Let us visualize this journey. Light from the cosmic microwave background has been traveling towards us for over 13 billion years. As this ancient light enters a supervoid, a region with less matter, it has to climb out of a slight gravitational valley. This process, known as the integrated Sachs-Wolf effect, should cause the light to lose a tiny amount of energy. When light loses energy, it appears cooler to us. So, as the photons pass through this immense emptiness, they are slightly chilled. It's like a cosmic toll booth, where light pays a small energy tax to cross the void. This could explain why that patch of the sky looks colder than the rest. For a time, this seemed like the most plausible answer. Astronomers pointed their telescopes toward the cold spot and began to map the galaxies in that direction. And they found something remarkable. They found the Eridanus Supervoid, one of the largest voids ever discovered, sitting right in front of the cold spot. It was a moment of seeming confirmation. A vast, empty region of space, spanning nearly 1 billion light years, perfectly aligned with a cosmic anomaly. It appeared the mystery was solved. The cold bruise was simply the shadow of an immense emptiness, a window into a quieter part of the cosmos. But science is rarely so simple. As our measurements became more precise, a new problem emerged. The Eridanus Supervoid is indeed massive. It is an incredible discovery in its own right. But when cosmologists ran the numbers, they found that it was not empty enough. It could not create a deep enough gravitational valley to account for the full temperature drop seen in the cold spot. The void could explain about half of the coldness, perhaps a little more. But a significant portion of the anomaly remained unaccounted for. The shadow was darker than the object casting it. The mystery, far from being solved, had only deepened. This is where our journey takes a turn, from the vast emptiness of space to the very fabric of reality itself. If a supervoid cannot fully explain the cold spot, what can? This question led some physicists to a far more exotic and mind-bending hypothesis. A hypothesis that suggests we are not alone in the cosmos, not in the way we usually imagine. It suggests that our entire universe is just one bubble in a vast cosmic foam of other universes. This is the theory of the multiverse. And the cold spot, according to this theory, is the first piece of physical evidence we have ever found for it. Imagine an endless ocean, and in this ocean, countless bubbles are forming. Each bubble is a universe with its own laws of physics, its own dimensions, its own destiny. Our universe is one such bubble, expanding since its own Big Bang. In the chaotic early moments of this cosmic foam, it's possible that our bubble universe bumped into another, a gentle cosmic collision between two separate realities. The impact would have sent ripples through the fabric of our own space-time, a shock wave of energy that would leave a lasting mark, a permanent scar on our infant universe. According to this theory, the cold spot is that scar. It is a cosmic bruise, left behind from an encounter with a parallel world. The interaction would have pulled energy out of that region of our universe, creating a permanent cold spot that would be visible forever in the cosmic microwave background. This is not a portal in the science fiction sense, not a doorway we can step through. It is more like a fossil. It is the preserved remnant of an event that happened at the dawn of time. A memory of a sibling universe that once drifted too close. It is an echo of another existence imprinted on our own. This idea, while speculative, is not pure fantasy. It is rooted in aspects of string theory and eternal inflation, which are leading frameworks for understanding the fundamental nature of reality. These theories mathematically predict that our universe should not be the only one. If this hypothesis is true, it means that when we look at the cold spot, we are gazing upon the edge of our own reality. We are seeing the tangible evidence that our entire cosmos, with its billions of galaxies, is just one small part of a much larger and far stranger whole. It redefines our place in existence. Of course, this is an extraordinary claim, and it requires extraordinary evidence. Currently, the multiverse hypothesis for the cold spot is just that, a hypothesis. There is no way to prove it definitively with our current technology. Scientists are working on more detailed maps of the cosmic microwave background, looking for specific patterns in the temperature and polarization of the light that might be the unique signature of a cosmic collision. These patterns would be distinct from those created by a simple void, offering a way to finally distinguish between the two possibilities. Let us drift back to the image of the supervoid. Even this more conventional explanation is filled with a quiet sense of wonder. To contemplate a region of space so empty that its very lack of substance can alter the ancient light of creation is profound. Imagine a silent journey through this void. For hundreds of millions of years, you would travel through a darkness deeper than any we know on Earth. The bright signposts of galaxies would be few and far between, distant smudges of light in an overwhelming emptiness. It is a place of ultimate tranquility, a testament to the universe's scale and its capacity for both density and nothingness. This emptiness invites us to think about our own place in the cosmos. We live in a relatively crowded neighborhood, the Milky Way galaxy, surrounded by hundreds of billions of stars. But the universe as a whole is defined more by its voids than by its galaxies. These quiet, empty spaces are the default state of the cosmos. Our existence, the existence of stars, planets, and life, is the exception. We are a flicker of complexity in an ocean of serene simplicity. The Eridanus Supervoid is a humbling reminder of this cosmic truth. Now let your mind drift back to the other possibility, the touch of another universe. What would that universe be like? Would its laws of physics be similar to ours or wildly different? Could it harbor forms of existence we cannot even imagine? The theory does not say. It only suggests a connection, a brief moment of contact at the beginning of time. It transforms the cold spot from a place of emptiness into a place of profound connection. It suggests that the boundaries of our reality are not absolute, that we are part of a cosmic family, even if we can never meet our relatives. This idea changes how we perceive the night sky. When you look up, you see points of light from within our own universe. But if this theory is correct, there is one spot in the constellation of the river where you are looking at the consequences of an event that originated outside of our reality. It is a bridge, not of matter or energy, but of information, a signpost pointing to something beyond the known. It fills the cold emptiness with a sense of infinite possibility. a feeling of awe at the sheer, unimaginable scope of all that might be. The debate between these two ideas continues. Is it a void, or is it a bruise? Perhaps it is a combination of both. Maybe a smaller supervoid exists in a region of space that was already slightly cooler due to a primordial fluctuation or some other yet unknown physical process. Science is a journey of slowly peeling back layers of mystery. And the cold spot is one of the deepest mysteries we have encountered. It is a puzzle handed to us from the very beginning of time, waiting for us to become clever enough to solve it. As we continue to observe this anomaly, we learn more not just about the cold spot, but about the universe as a whole. Every new piece of data, every refined measurement, sharpens our understanding of the Big Bang and the fundamental laws that govern our world. The cold spot acts as a cosmic laboratory, a natural experiment of immense proportions that pushes our theories to their absolute limits. It forces us to ask bigger questions and to imagine possibilities that once seemed to belong only to philosophy or fiction. Consider the silence of this place. Whether it is a void or the scar of a cosmic collision, it is a place of deep quiet, a region of the universe less disturbed than any other. In our busy, noisy world, the thought of such a vast and peaceful emptiness can be deeply calming. It is a reminder that beyond our immediate concerns, there exists a scale of time and space where our anxieties become infinitesimally small. The cold spot is a meditation on emptiness, stillness, and the profound beauty of the unknown. The search for answers will continue. New telescopes, both on Earth and in space, will stare into the ancient light of the CMB with ever greater clarity. They will map the Eridanus Supervoid with more precision, counting every last distant galaxy to determine its true density. And they will search for the subtle signs, the telltale patterns that could confirm or deny the collision of universes. The final answer may not come in our lifetime, but the journey itself is what matters. The act of looking out into the grand darkness and asking, what is out there? And so, as we float here at the edge of this cosmic question mark, we are left with a feeling of profound wonder. The universe is not a perfectly smooth and predictable place. It has texture. It has history. It has scars. The cold spot is one of its most prominent features, a landmark on the map of creation. Whether it marks a great emptiness within our universe or a point of contact with another, it serves as a powerful symbol. It tells us that there are still great mysteries to explore, and that the cosmos is far more strange and far more magnificent than we can possibly imagine. So, what is the cosmic cold spot? Is it the shadow of a great void, a window into the quiet emptiness that dominates the universe? Or is it something more? A fossilized bruise from a collision with a parallel reality, the first clue that we live in a sprawling multiverse of infinite possibilities. For now, the universe holds its secret close. The mystery remains, a silent, cold patch on the baby picture of our world, inviting us to wonder, to dream, and to continue exploring. Thank you for joining this journey into the quiet depths of space. If this voyage helped you relax, please consider liking the video and subscribing for more lectures on the cosmos. And now, as you drift off to sleep, I leave you with one final question to ponder. if the cold spot is a door to another universe? What do you imagine lies on the other side? Share your dreams in the comments below. Sleep well.